Welcome to QRiskTree Editor. This tool is the main user interface for a library called QRiskTree, which implements a process to decompose risk and evaluate possible mitigations to determine if they are convenient or not. Let's consider, for example, a potential risk, like the exfiltration of sensitive data from some database. We can decompose the risk in its main components. Methodologies like open-fair help us to do so and to estimate the potential losses by decomposing the risk in its constituent components. This is useful to determine if the risk is significant enough to invest some resources on it. In fact, you might decide to accept a risk that might lead to a loss of $1,000 in the next year. If you decide to do something, you have multiple options, including hardening the server, tightening access control, filtering data, encrypting data at rest with transparent encryption, and adopting client-side encryption. All of them have different effectiveness and different costs. What does it mean, effectiveness? It means that if you apply a mitigation, it will lower the residual risk. Therefore, applying a new mitigation will further reduce the risk, but not as much as the previous one, given that the residual risk has already been reduced. In other words, applying multiple mitigations provides diminishing returns. At a certain point, the cost we have for a mitigation will be higher than the reduction of the risk it can provide. When that happens, it becomes economically unviable to apply the new mitigation. This consideration is key to understand what QRiskTree tries to accomplish. Given a complex system which is potentially affected by multiple causes of loss, determine in a credible and somewhat proven way what needs to be done to optimize the overall cost for the organization, where such optimization considers both the residual risk that you would have if you do nothing, the effectiveness, and the implementation and operation cost of the mitigations you have identified. This is a revolutionary change for security, with the potential of representing a bridge between security and business decisions. That's it with the introduction. This presentation is just to introduce you to QRiskTree Editor, not to describe in-depth quantitative risk analysis. If you are interested in learning more, you should read books like Douglas W. Hubbard and Richard Sayerson's How to Measure Anything in Cybersecurity Risk, or Jack Freund and Jack Jones' Measuring and Managing Information Risk. Check the material on open-fair published by the Open Group or FAIR Institute's vast documentation on FAIR methodology. So, let's move to QRiskTree Editor. As you can see, we have already opened QRiskTree Editor. As you open it, it already shows an empty document. You have four main views: the model, which shows properties like the name and the description. You can specify here the name and description of your application or service. There are also other properties for the simulation. The min and max percentile describe respectively what min and max mean. You must know that the tool works with ranges, which are described by a min, a max, a mode, which is the most probable value, and a confidence, which determines how flat the probability curve is. In other words, low confidence means that the curve is very flat. Therefore, each value between min and max has similar probability, and the mode is not much more probable than other values. High confidence means that the mode and the values near it are much more probable than the other values. Given that such ranges are an estimation, we cannot be 100% sure of them. To account for it, we define min and max by assigning them a percentile. For example, if we say that min corresponds to the 10th percentile, which is the default for QRiskTree, we say that we expect that the value we get in reality is lower than our estimation in 10% of the cases. Analogously, if we say that the percentile for max is 90, we expect that our estimation is lower than the reality for 10% of the cases. You can also express this by saying that you are 80% sure that your estimation is correct. Another parameter defined in the model properties are the number of iterations for the Monte Carlo simulation, which by default is 100,000. This number should be fine in most cases. You should increase it to get better precision and decrease to accelerate the calculation. The last two parameters are used to control how the mitigation optimization is determined. The first one, Optimize For, identifies what should be minimized, and it can be set to min, mode, or max. You would use mode in most cases, but you might want to set it to max if you want to minimize the losses in the worst-case scenario. The other parameter, ignore implementation costs, is normally unchecked. You should leave it as it is in most cases, but you might want to check it if you want to ensure that the costs after the first year are as low as possible. Let's move to the second page, the risks. This is where you define the risks for your system. You are supposed to manually enter them. To create a new risk, you can either open the context menu using the right mouse button on an empty spot and then click Create a new risk, or use the Edit menu. After you have created the risk, you can set your estimation as a range. You can now see Set by User as an X because it is undefined. You usually do not want to set your estimation at the risk level because you rarely have the information to estimate the risk directly. To go down a level, use the context menu on the newly created risk. You see that you have Add Loss Event Frequency and Add Loss Magnitude. These are the components for the second level. Create both of them and then click the plus button at the left of the row to drill down. Now you can set your estimation as a range or go down another level. The context menus guide you in what you can do and what you cannot because they are driven by the context. All of them include the ability to delete the selected object, but most of the other actions in the context menus are determined by the status of selected object and of the model. For example, set some estimation for the loss event frequency. Frequencies are expressed as events per year. Therefore, a min of 12 means once per month, a mode of 60 means 5 times per month, and a max of 240 means 20 times per month. You can click the Tab button to move between the columns and then click Enter to finalize your estimation. After you do that, you will see that the Set by User column has now a tick instead of the X. If you open the context menu on the loss event frequency again, you can notice that now there is a new option, Reset the Range. This allows you to remove your estimation and revert the row to its initial state. Ranges can be of various types. We have already seen the frequencies. You can also have monetary ranges and percentages. Frequencies can be identified because you have plain numbers. Monetary ranges and percentages have respectively the currency symbol and the percentage. For example, you can see here that the currency symbol is the dollar. QRiskTree Editor uses the default currency symbol you have defined in Windows. Finally, percentages can be recognized because they have the percent symbol. You can input percentages in two ways, as decimal numbers without the percentage symbol or as numbers with the percentage symbol. This means that you can insert 12.5% as 0.125 or as 12.5%. The third page is dedicated to mitigations. You can create new mitigations by opening the context menu on an empty space and then selecting Create New Mitigation. As usual, you can do that using the right mouse button. This will immediately create an empty mitigation object. You can easily change the name of the mitigation and specify the implementation costs directly in the row. The yearly operation costs must be specified in the properties of the mitigation. Again, they are expressed as a range. You can assign a mitigation to a risk by returning to the risk page and then selecting the risk you want to operate on. If you open the context menu on the risk with the right mouse button, you can now see a new command, Associate a Mitigation. This command is shown when you have at least a mitigation that has not been already associated with the selected risk. Click that command and now you will see a dialog asking you to select the mitigation to be associated with the risk. If you select a mitigation and then click OK, you will see the mitigation in a table under the risk. Such mitigation requires you to specify a percentage range. Such percentage range allows you to specify the effectiveness of the mitigation. For example, if you specify 10%, it means that the mitigation is able to save 10% of the cost you would face due to the risk. This means that if you have a cost of $1 million, the mitigation will save you $100,000, and the residual risk will now be $900,000. After you have registered all your risks and mitigations, assigned the threats with the corresponding mitigations, and completed their configuration, it's time to calculate the baseline risk and identify the optimal set of mitigations. To do so, you can use the Calculate menu. If you click there, you can find two distinct actions, calculate baseline, and calculate optimal mitigations. You should start with calculating the baseline, as the second provides evaluations based on its results. Before calculating the baseline, the QRiskTree Editor verifies if the model is complete, and if not, it stops specifying what is the issue. Please fix the eventual problem and retry. It might be necessary to repeat this action more than once if you have multiple issues in your model. Ultimately, the calculation will be completed and you will obtain the annualized loss expectancy related to the whole system described with its potential risks expressed as a range. The results of the calculation are shown in the Output panel, which is this black box at the bottom of the QRiskTree Editor. You can also see the results of the calculations in the risk page because every row that has not received your estimation will be set with the last calculated range. You can easily identify such calculated rows because their set by user column has an X. At this point, you can execute the calculation of the optimal mitigations. Before starting with the actual calculation, the QRiskTree Editor performs the same validation it does for the baseline. If everything is fine, the actual calculation will start. It typically takes a much longer time to calculate the optimal set of mitigations than to calculate the baseline. The baseline calculation should take a few seconds even for the most complex systems, while the calculation of the optimal set of mitigations might take a few minutes or even hours, depending on the number of risks and mitigations. As a reference, a powerful notebook with a top-of-the-line AMD processor for 2024 takes 20 to over 30 minutes to analyze a system with 10 different risks and 10 mitigations, where each mitigation is applied to every risk. This is using the default settings. You can cut time by reducing the number of iterations. For example, if you specify 10,000 instead of 100,000, the time is cut by an order of magnitude. The good news is that you can continue to use your computer while the calculation is in progress, as it uses a little more than one logical processor. QRiskTree Editor estimates in a very rough way the time required to complete the execution before starting it and asks you to confirm the operation if it is determined that it will take more than 30 seconds. Please consider that the estimated duration is purely indicative, and a difference by a factor of 2 or more is entirely possible. At the end of the calculation, you receive the indication of what is the optimal set of mitigations and the evaluation as a range of the overall cost for the first year, which includes both the implementation and operational costs of the optimal mitigations, and for the following years, which includes only the operational costs. If you executed the calculation of the baseline before performing the calculation of the optimal set of mitigations, you also get an evaluation of how much the selected mitigation will save you compared with the baseline. Let's move to the fourth page, the facts. You can register here the information you collect and use to perform the estimations. You will then be able to assign these facts to most rows in the risks and mitigations pages using the context menu. The approach is similar to the assignment of the mitigations to the risks. Remember that most rows can be assigned facts, not only the risks. For example, the components of the risks can be assigned facts. You cannot assign facts to the applied mitigations, to the linked objects in the mitigations page, or to the facts themselves. There are various types of facts you can create. Simple facts allow just a number. Then you have facts allowing to specify monetary ranges, percentage ranges, or frequency ranges. It is important to note that you cannot edit the fact value in the row. You must edit it in its properties. This is because ranges are defined in a very different way than simple facts. Each fact has a few specific fields you should understand. The first one is the context, which can be used to specify where the fact applies. For example, if your company develops multiple applications, you could specify the name of the application in the context. Another important field is the source, which typically is the name of the expert who provided you with the information or the URL where you can find it. Then you have the reference date, which contains the date when the data was actual or the collection date. We have almost completed our review of the QRiskTree Editor. The only remaining step is to get a look at the menus. The first one, File, doesn't have anything peculiar. Therefore, we'll skip it. The second one, Edit, allows you to create the various objects, risks, mitigations, and facts. It also allows you to clear the output panel. The View menu contains actions you can use to show or hide some parts of the QRiskTree Editor, mainly the property panels and the output panel. We have already seen the Calculate menu. Therefore, we can skip it and move to the next one, which is the Import menu. This is used to import some files. The first action is to import facts. The QRiskTree Editor allows you to export the facts you define to a JSON file so that you can import it on another model and use these facts there. The intent is to allow the creation of collections of facts you can reuse. You can also find in the import the possibility to import files generated with Microsoft Threat Modeling Tool or in the Open Threat Model format. The first category of files creates a list of threats, while the second imports also the mitigations. As a side note, you might have noticed that the context menu of the risks includes an action we didn't discuss. That would be the ability to clone the risks. This feature has been introduced because importing the threat modeling tool files creates a single risk for all the instances of the same threat. In fact, each risk includes a list of flows where the threat is applied. This might be fine in various situations, but not all. In some cases, the risks might be formally similar, but not at all the same in reality. For example, the risk of tampering of data at rest is very different if we are talking about a database or the storage of applications artifacts to be deployed on the clients. The potential losses have different nature, and they must be addressed in different ways. Still, they might be represented as a single risk in the threat modeling tool file. For this reason, you might need a tool to duplicate the threat. Of course, you can use the same functionality for your own purposes. Last, we have the Export menu. It contains the action to export the facts, which we already discussed, and the one to export the content of the output panel as a text file. You might have noticed a few other differences between your version of the QRiskTree Editor and what we have discussed here. This is because you might have a more recent version of the QRiskTree Editor. This recording has been prepared for version 0.1.1. While we are not planning to change too much this tool over time, as it ultimately is intended to be a basic interface over QRiskTree, we will definitely implement fixes and a few quality of life changes whenever deemed necessary. That's it for this recording. If you need further clarification, please ask your questions in the discussions page of the GitHub repo for QRiskTree. Thank you for watching.